Yeah.
Number one.
Okay. All right. So number one, we want to start by identifying our asymptotes. So I noticed that this one is in that form 1. So the horizontal asymptote is just y equals k. So in this case, that's -3. And the vertical asymptote in form 1 is x equals h. So in this case, that's -2. So my domain is everything except the vertical asymptote. Oh, but we weren't going to write it that way. We're going to do it with the unions, right? I'm doing other class also, and there's a slightly different standard when it comes to writing domains and ranges there. We're a little less formal. So I just was in that mode there for a second. My apologies. So far, so good, Alyssa?
Mm-hmm.
Okay. The middle of my table is the vertical asymptote, and then I'm going to pick any 3 points less than that and any 3 points greater than that. So not going to do anything tricky, just going to use whole numbers. When I plug these in then, when I plug -5 in, I get 1 over -3, so that's like -3 1/3. When I plug the -4 in, that's 1 over -2, so that's like -3 1/2. I plug the -3 in, that's 1 over -1, so that's -4. And when I plug the -1 in, that's 1 over 1, so that's -2. I plug the 0 in, that's 1 over 2, so that's -2 1/2. And I plug the 1 in, that's 1 over 3, so that's -2 2/3. Does that all look good so far? I was going fast, so if I go too fast, holler at me or whatever. But you guys are pretty sharp, and I'm just plugging stuff in, so I assume that you got it, but if you don't, that's okay, just speak up. So I drew my vertical asymptote at -1. Except that's the wrong spot because it's supposed to be at -2. I apparently can't read. Good thing I double checked. So there's my vertical asymptote at -2. And my horizontal asymptote at -3. And then I'm just going to go ahead and start plotting my points. So -5 and -3 1/3. And then -4 and -3 1/2. And then -3 and -4. So if I draw my graph, then it looks something like that. And we'll go and do the other one. So I have -1, -2, 0, -2 1/2, and then 1, -2 2/3. So I could just go and do the other. Cool there, Al?
Mm-hmm. Thank you.
Yeah, no problem, my dude. All right. So let's go to the general rational functions and start doing some examples of those. I think we had gone through how to find all the key features last time. What we want to do this time is do some examples of the couple different situations and kind of show you how to take those, what we know about the key features, and kind of put them together into making an XY table and getting a reasonable graph out of this. Okay with that? All right. So let's go ahead and just continue talking about general rational functions. And let's do an example here. So let's say we have x plus 1 over x squared minus 4. So far, so good. You know, whatevs, right? All right, so the first thing first, I'm going to find my, check to see if I can reduce this, actually. It's really the first thing I want to do. The numerator obviously doesn't factor, and the denominator is clearly a difference of 2 squares. So no reducing that I can do there. But I do need to check, right, just in case. Okay. So I will start by finding my vertical asymptotes. I do that by setting the denominator equal to 0 and solving. So I get 2 vertical asymptotes at -2 and +2. Everybody good there? I'll find my x-intercepts next. I get the x-intercepts by setting the numerator equal to 0. So if I do that, I get -1. And I'm going to remember to write my x-intercept as a point, because it's very easy to get confused and start thinking that's another asymptote or something. So I'm going to make sure that when I solve for x, I'm going to write it as a point, just to make sure I don't screw that up, because it's easy to do that, to get confused at what you're doing. Everybody's okay there? Okay. I'll find my y-intercept next, and I just get that by putting 0 in for x. Everybody good with that? Because that just gives me 1 over -4, right? So far, so good? Okay. So other asymptotes and end behaviors. I notice the degree of the numerator is 1. The degree of the denominator is 2. Since the degree of the numerator is less than the degree of the denominator, I know that I have a horizontal asymptote or end behavior at y equals 0. Now, I've done enough already to know immediately whether I'm talking about an asymptote or end behavior here. Can anybody look at what we have and know for sure? There's enough information to tell. Remember, an asymptote is never crossed, but an end behavior could be crossed in the middle, but the ends of the graph should be never crossing. So does this graph cross y equals 0, otherwise known as the x-axis? Well, definitely does, right? I have an x-intercept. So I know that this is really, the end behavior rather than the asymptote. Mackenzie. I just did degree n is less than degree d. N for numerator, d for denominator. I was just making some abbreviations. Is that okay with you guys? Okay, so it's important to know that basically there is going to be a place where I'm going to draw in the dashed line for the horizontal asymptote, but it's okay if I cross it in the middle, but the ends of the graph should be following it. Okay with that plan? All right. So what I'm going to do is I'm going to make an XY table. And I'm going to basically use the same criteria I did before, where I'm going to have 3 points on either side of my vertical asymptote. But this time I have 2 vertical asymptotes. So I'm going to need 3 points, and then my vertical asymptote, 3 points, and my other vertical asymptote, and then 3 more points. Everybody's okay there? Okay, I'm going to go ahead and choose these any old way, because in this situation, where our horizontal asymptote is at 0, or our end behavior is at 0, it's not a difficult one to kind of get a decent graph to come out of. So I don't have to be too careful here. And again, these guys are shaded in. Now, a couple of these, I know what's going on, right? At 0, I know that's negative 0.25, because that was my y-intercept, right? And I know at negative 1, that was 0, because that was the x-intercept. So I got 2 of the points for free. I don't have to plug those in. The rest of these, though, I'm going to plug in. And probably the easiest way to get those points to come out is to use our calculator, because here the numbers are complicated enough that it's just kind of a pain in the butts. So I'm going to just fix my calculator here a little bit. I was using it for a different class and had it in a very different mode than what we're accustomed to doing. So just don't mind me until I got it reset in a way that you guys will be familiar with. But what I'm going to do is I'm going to go to the y equals menu, clear out what's there, and I'm going to do the numerator, which I think was x plus 1, in parentheses, divided by the denominator, in parentheses, x squared minus 4. So I made sure to put the whole numerator and whole denominator in parentheses. And this is just, all I'm doing is really I'm plugging in values of x to get the values of y. But I'm going to use my calculator to do it kind of all at once. And then what I'm going to do is I'm going to press second, and I'm going to press the window button, which opens up the table setup menu. So I'm going to build an XY table on my calculator. I want it to start at negative 5. And I want it to go up by 1s, which is basically looks exactly like the table I've written down on my sheet of paper, right? So to look at that table then, I press second and the graph button. And I'm just going to copy down some of these values now. Just do that real quick. So I have negative 0.9, negative 0.25, negative 0.4, 0.25, negative 7. And I need to scroll down now for a little bit more. Notice where the asymptotes are. What am I getting as a y coordinate there? I'm getting error, which is how your calculator communicates to you that there's like no y coordinate there. That's why we drew the little, we filled in the boxes there where those asymptotes would go. So far, so good. So I'm going to draw my graph now. see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, on my y-axis, what do you think I should go up by? Look at all my y-coordinates. They're all like less than 1, right? What should I go up by? What should I scale my y-axis as? How about 0.1? Does that seem good to you guys? Obviously, going up by 1s would be kind of a problem, considering looking at all the values are all between -1 and +1. It'd be tough to fit those on there. But if I go up by like tenths, that'll be pretty good, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll put a 1 at the top to show that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll put a -1 down here to show that. Okay, vertical asymptotes here at -2 and +2. And then I have a behavior. Now, it's hard to see that on your sheet of paper, so what I'd ask you guys to do is to just also label the, next to it if you can't really see it because it's on the axis like that. Is everybody okay with that idea? So I just wrote it. I mean, I drew it, but you couldn't really tell that I drew it, especially if you are working with pencils, right? If you want to use color coding, like you don't have to bother to write that next to it. That's fine. But you have to do something to communicate that you know there's an asymptote or end behavior there. Whether that's using a different color or just writing a label, either is fine for me. Okay? Let's plot some points then. Let's see. So -5 and -1.9, -4 and -0.25, and then -3 and -0.4. And then we have -1 and 0, 0 and -0.25, and then 1 and -0.67. And then we have 0.8, 0.42, and then 0.29. Everybody's cool with that? And just again to point out, there's the place where the graph does cross y = 0, which means that we have an end behavior rather than an asymptote. Everybody's okay with that? Again, nothing special you need to do here. I won't even mark you down if you called that an asymptote instead of an end behavior. That's not a big deal to me, as long as your graph is correct. But I figure as long as we're on the topic, I want to just kind of hammer that vocab a little bit. Okie dokie. The natural question would be, what do I do if there's no vertical asymptote? So similar type of problem. Let's say we have something like this. I'd get an imaginary solution when I try to solve for a vertical asymptote, which tells me there aren't any. If I try to solve for or find an x-intercept, well, 5 doesn't equal 0. If I set the numerator equal to 0, there's nothing to do there, so there's none of those. I have a y-intercept. just at 0, 5. And this is, again, an HA or EB at y equals 0. Same situation as before, right? Where the degree of the numerator is 0, the degree of the denominator is 2. So, and in fact, you can tell from this situation that this one's an asymptote because there's no place where the graph crosses the x-axis. Well, what do you suppose we should use our put in the middle of our x? In general, if there's no vertical asymptotes, let's just use 0. Typically will give you a good graph, but there's no set rule as to what to do. That's what I usually do, though. And I happen to know here that my y-intercept, so I know the point there already. Yeah. It's the same situation as the previous one. The degree of the numerator is less than the degree of the denominator.
Okay.
So this is the only situation where I can tell just from the basic information which one I have. And it's the fact that I know that y equals 0 is the same as the x-axis, right? And there are no x-intercepts, so the graph never crosses the x-axis. So it's got to be an asymptote as opposed to an end behavior. The ones that will not be nearly as cut and dry. Or the other two situations, I should say.
So how would you find it?
Well, you can still find it, you just can't identify without looking or without plotting stuff necessarily if it's an asymptote or an end behavior.
You have to graph it.
You probably have to graph it. So I'll go get my stuff. And in fact, I don't even really need the calculator to do this. This is easy enough. So -3 gives me 9 plus 1, which is 10. 5 divided by 10 is, I plug in 2, -2. -2 squared is 4. 4 plus 1 is 5. 5 over 5 is 1. I plug -1 in. -1 squared is 1. 1 plus 1 is 2. 5 divided by 2 is 2.5. And I get the same results for positives as I will. Is everybody okay there? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. I have just my horizontal asymptote here. And then -3 and 0.5, 2 and 1, -1 and 2.5, 0 and 0.5, and then kind of the same over here. So it just kind of looks like a hill. Yes.
What does it say under y?
0, 5. And let's do another one. So let's say we have, bless you. You're welcome. Let's do 4 minus 4x So here, I'm going to start by factoring. Again, we didn't factor the previous one because there's no factoring to do. I guess I neglected to say that right at the beginning, right? But 5 over x squared plus 1 should have been pretty easy to see that. From the numerator, I can take out a 4x as the greatest common factor, and the denominator is a different. Nothing to reduce, though, right? We'll see what happens when we have to reduce in the next example. That's on my to-do list. So far, so good? Everybody's okay? Again, if I'm going too fast through something, or if I breeze through a detail that you're not sure about, stop me and ask. I'm happy to elaborate more, but you know, I figure doing a lot of examples, I have to go a little bit quick to do a lot of them. But if that's too fast or whatever, just stop me and let me know. I can slow down. Vertical asymptotes, so we'll take our denominator and set it equal to 0. So I get 3 and negative 3. My x-intercept, I'll set the numerator equal to 0. So I'll get 0 and, but again, with my x-intercepts, I like to write them as squares because I don't want to get confused and accidentally put them in as asymptotes or something, since x equals 0 and x equals 1 looks like asymptotes, right? Still doing okay, everybody? Do I need to pause here, let you guys catch up? See lots of pens moving. It's okay, just say something. All right, well, so the y-intercept, I don't really have to do anything because look at this right here. That y-coordinate is 0, isn't it? Is it not? So I know that that point is also my y-intercept. That happens on occasion that the x and y-intercept are the same value when the origin's involved. I could also have gotten that by plugging 0 in for x. That would have been fine too. You'll get 0 over 9, negative 9, still 0, right? Is everybody okay there? Okay.
How do you find the other again?
That's what we're going to do.
Sorry.
That's okay. So again, here, to find the others, we have to compare the degrees. So the degree of the numerator is 2. The degree of the denominator is 2. And since the degree of the numerator is equal to the degree of the denominator, that tells me that my horizontal asymptote or end behavior is y equals the leading coefficient of the numerator over the leading coefficient of the denominator. In this case, that's 4 over 1. So just y equals 4.
And if one is higher, it's that one, right? It's the numerator. If like one is higher.
So there's 3 situations. Okay, if the numerator is less than the denominator, it's 0. Y equals 0. If they're equal, it's leading coefficient over leading coefficient. If the numerator is greater, we'll see that situation next.
Okay.
But it was in your notes last time too, so it was the last topic we did in the notes last time also. But we'll review it again when we get to it. Okay?
Okay.
Everybody so far so good? Okay. Let's make our table. Let's see. I need 3 points. My vertical asymptote. 1, 2, 3 points. My other vertical asymptote. And then my 3 points. Now here I want to be a little bit careful. So notice what I did there in between -3 and +3. I tried to keep the points symmetric, right? I had a point right next to -3 and +3, and then something that's kind of in the middle of those two. Yeah, Tay.
Oh, I'm just stretching.
Oh,
Sorry.
no problem. You stretch on. I'll just, as long as I know you're not asking a question, you're free. Go ahead, stretch it out. Okay, so we have that part. I know that this 0 is the x-intercept and the y-intercept. And I know that I also have an x-intercept at 1. I didn't put that on my table, though. I'm just going to do one of these. Oops. And just make a little note of it to myself, that when I'm graphing, that I can put that in there. And then I think I'm ready to start finding my points. You guys cool with that? So I'm going to use my calculator to do this, because again, it's kind of a hassle doing it by hand. So 4x squared minus 4x, all that in parentheses, divided by x squared minus 9, all that in parentheses. And then my table set, I'm going to reset that back to start at -6 and go and pull that up. So I have 6.2, 7.5, and 11.4. Again, I'm graphing, so it's totally reasonable to just leave these with 1 decimal point. -0, I knew that already, and then -1.6. And then 4, oops, got to go down some more, is 6.9, 4.4, oops, no, 5, and then 4.4. Coolsville, everybody? Okay. Go ahead and draw our graph. Let's see, 1, 2, 5, 6. 1, 2, 3, 4, 5, 6. I got to go down to at least -5. 1, 2, 3, 4, 5. And I got to go up to, well, past 11. So let's do 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a vertical asymptote at x equals -3 and +3. And then I have my horizontal asymptote, or again, I don't know for sure which one it is. Even by maybe looking at the table, it's not entirely clear to us. I mean, it is, I guess, relatively clear, but oh, I guess no, it's not clear at all. Well, I mean, no, it's totally clear. Sorry. Anyways, so start graphing. So -6 and 6.2 is like here-ish. -5 and 7.5 is like there. And then -4 and positive 11.4 is like there. So we'll do one of these. Everybody cool there? Okay, so -2 and -4.8, like there. 0, 0, 1, 0, and 2, negative 1.6. Now I have a little bit of a conundrum here. What's my conundrum when I'm going to draw? Well, my question would be, what's happening between 0 and 1? Should the graph be above the x-axis or should it be below? I mean, I would think that it's probably above, but I'm not sure. What should I do? Just find another point in between to know for sure, right? What's an x value between 0 and 1?
0.5.
Yeah, 0.5. So let's just try that real quick. So I have 4 times 0.5 squared minus 4 times 0.5 over 0.5 squared minus 9. So that's above. And it was like 0.11 something or whatever, right? Everybody cool with that? So again, if you have 2 points that are like right next to each other on the same horizontal line, you kind of need to know, like, does the graph go above that horizontal line or below it? You don't really know. So you just pick another point in between and just make sure. You probably have a good idea, but sometimes you can get surprised. You know, like weird stuff happens every once in a while. And the last half. So 4, 6.9 is like there. And then 5, 5 is like there. And 6, 4 is there. What do you notice about 6, 4? Oh, 6 is 4.4. That's much better. I was like really kind of surprised by that. 4. That's much better. What would have been weird about 4? It's the asymptote or end behavior, right? Usually if something's going to happen, it would be like in this section here, if it was going to do any crossing. That would be the candidate that I would find likely to see that, not out towards the ends. Is that cool with you guys? Okay. How's this going so far? It's not bad, but there's kind of a lot to do and a lot to keep track of. Sometimes they can be weird, especially if you make like a little mistake along the way. Like things can get very goofy if you've made a little mistake and you have an asymptote in the wrong spot or whatever, and like stuff just stops making sense. Oftentimes that's a good indicator that there's a mistake, or you like misidentified the situation or something like that. Well, let's keep going. We'll do at least one more example and then we'll stop and see how you guys are doing, and maybe we start, just give you time to work on the stuff in class so you have a chance to ask questions if you run into stuff. I can't imagine that we can do like an hour and 20 minutes of examples, like shoot me in the head, right? You're probably already close to that point right now, so I commend you for making it this far. All right, let's do at least one more, and then we'll see how things are going. Let's do +1. Oh, no, I don't want to do that. Sorry. Hold on 1 second. I forgot I was trying to include that situation too. X squared plus x. There we go. Okay. First step. Let's check to see if we can factor. There's a whole bunch of factoring that can happen here though, right? So hopefully right away you notice that there's a greatest common factor in the numerator. When you pull that greatest common factor, you should see the two things that multiply to give us negative 10 and add to give us negative 3 are negative 5 and positive 2. And in the denominator, I also notice there's a greatest common factor of x. So there's that. Everybody's okay here? Okay. Notice that this time there is some reducing to do. Everybody see that? So that creates a restriction at x cannot, or that x cannot equal 0. And in terms of our graph, that's going to create a removable discontinuity. So to find that removable discontinuity, we're going to take 0 and plug it into the reduced function. So the point 0, negative 10 needs to be included in our graph, but it needs to be an open point as opposed to a closed point. Okay? So again, if you're able to reduce, which happens infrequently, but every once in a while you can, the restriction caused by that reduction, or if a restriction is caused by that reducing, that creates a removable discontinuity. The x-coordinate is the x-coordinate for any restrictions. To find the y-coordinate, you plug it into the reduced function to get the y-coordinate. Is that okay? First time that's happened for us, but it's not a big deal, but it's, you got to be careful about it. Now let's go ahead and find our stuff. Our vertical asymptote, we take the reduced denominator and set it equal to 0. So I get just one vertical asymptote. To find my x-intercept and set it equal to 0, 2 x-intercepts. My y-intercept does not exist. Well, I guess in this case, it's the same as the removable discontinuity. There is no y-intercept because the removable discontinuity is not actually a point, but I'll just put RD there for it. Because 0, when we plug into our function, we do get a point from it, but it's not an actual point. It's an open circle there. Everybody's okay with that idea? Okay. And then the other stuff, here I notice the degree of the numerator is 2, and the degree of the denominator is 1. So since the degree of the numerator is greater than the degree of the denominator, we get the slant And how do we find that slant asymptote? Well, the way we find that slant asymptote is we take our numerator and we divide it by our denominator. So in this case, or to do polynomial division, I have two choices. I can either do long division or synthetic division sometimes, right? Synthetic division only works sometimes. Does it work in this case? Yes. Why? The denominator, or the divisor, is degree 1 and has leading coefficient 1. So we're good to go there. So I'm going to use synthetic division because, well, it's a lot than long division. Everybody's okay there? So what this tells me is that my rational function could be rewritten as x minus 4 plus negative 6 over x plus 1. Right? We remember that this is the remainder, the constant, and the x coefficient. So everybody so far so good? Is my slant asymptote. This is the most complicated situation where you have to do that polynomial division to get your other asymptote out of there. And again, this could be an end behavior also. I don't know if it's going to cross or not right now anyways. It's hard to tell without an XY table. You ready to start constructing something? Okay. So I'm going to start by making a XY table with 3 points on either side of my vertical asymptote. Now 0, I notice, is my removable discontinuity, so I'm going to label that. Negative 2 was an x-intercept. Let me label that. And then these other ones, let's go find out the values for. It's worth pointing out here also that 5, 0 is another x-intercept out here. See if we can get a decent looking picture out of this. This is usually the most challenging one to get a decent picture of, doing what we'd normally expect. Questions from anybody yet? It's okay if you do, just holler at me and I'll address them the best I can. Let's see, we have negative 6, negative 4. We have our negative 10, and we have another negative 6, negative 4. Okay. But this is not the only XY table I need to make for this situation. What else do I need to graph? I also have to graph my slant asymptote, right? My slant asymptote is not a horizontal or vertical line, so I need to have some points to create it. What shape of, or what is that, what kind of function is that slant asymptote? It's a linear function, right? How many points do we need to graph a line? 2. Everybody agree with that? Okay. So I can pick any old x's and plug them in to get the y's, right? So the x's I'm going to pick 0, which gives me the y coordinate -4. And I'm going to pick the x value of 4, which gives me the y coordinate 0. Everybody good with what I did there? Just plugged them into y equals x minus 4. Pick any x's you want. I like picking them far apart because I think I get a better picture, because it helps offset the messiness of my penmanship. But you could have done like 0, 1. Like, that's not wrong to do that. I just know that I myself have a bad track record when it comes to doing stuff like that. Let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then let's put in our asymptote. So -1 is my vertical. And then 0, -4. And then 4, 0. So there's my slant asymptote. Everybody so far so good? All right, so -4, -6 is like here. Oh, that can't be right. It has to be like here. 4, 5, 6. Okay. And then -4 or -3, -4 is like there. And then -2, 0. So this one I'm going to be following the slant asymptote, come through my points, and then follow my vertical asymptote. Come in. What's going on, J-Dog?
Hi.
Thank you. Mackenzie, you got a get out of jail free card, my dude. You're welcome. And then let's do the other one. So 0, -10. Remember this one, though. Open circle. If I don't see that, I'm marking it down. And then 1, -6. So that's like there-ish. And then 2, -4, which is like there. Make that a little longer. So it's going to look something like that. What do you guys think? It's all right? Who's ready to stop examples and just have some time to do some stuff on their own? I think we're probably good. I think we've seen a good assortment of stuff. All the tricky things that I think can happen we've looked at. Not to say there won't still be something you run into and you're like, I'm having trouble sorting this thing out. But that's okay. That's why we're doing homework, right?